In this video, we're continuing section 5.1 on exponential functions, and we're going to solve some harder exponential equations. So let's get right into an example. So we have 4 to the x power minus 2 to the 3 plus x minus 128 equals 0. So one of the things that makes this equation harder than the ones that we've seen before is that, well, we have several terms. We have 3 terms here. Typically, we've just seen 2 terms. But also, these terms don't all have the same base. So one thing I'm going to try to do, if possible, is see, can we get a common base? Can we get a common base with at least some of these? And the ones that I'm going to focus on are the ones that have the x's and the exponents. So 4 to the x, and this 2 to the 3 plus x. Okay, so with the 4 to the x, 4, I'm going to write this on the side, is 2 squared. So that gets a common base for us. We'll get 2 squared. In fact, you know what? Let me just move that closer. We got 2 squared to the x power. And then with that next term, I'm going to use an exponent property as well to split it up. So that's the same thing as 2 to the 3 and then 2 to the x being multiplied together. Because when you multiply 2 to a power times 2 to a power, those exponents add together. Okay, so we get this, and then we also have that minus 128 equals 0. So one nice thing about that first portion, that 2 to the x, is that, well, this is the same thing as 2 to the x first, and then that thing being squared. Because with both of these, if you have a power to a power, the exponents get multiplied. So they're both, if you multiply both of these powers in either form, you'll get 2 to the 2x. Both of them are 2 to the 2x, so they're equal to each other. But having it in this form, I'm going to highlight, is very nice because I see 2 to the x here, and I also see 2 to the x there. So that's suggesting that maybe we can substitute for that thing. So let's pick a new variable, like y, and let's let y be 2 to the x. And substituting now, I'll put an arrow. So this implies the first term becomes y squared, and you get minus 2 cubed is 8 times y minus 128, and that equals 0. Okay, so this was a hidden quadratic. Making this substitution turned it into a quadratic. All right, so now let's try to factor this. So let us try to factor this quadratic. So I know we'll have a y, and we'll have a y. We need 2 numbers that multiply to negative 128, and they add up to negative 8. So it turns out what works, we may have to try it for a little bit, but it turns out what works is minus 16, and then plus 8. Okay, and now that it's factored in equals 0, we can say what y equals. From the first parentheses, we get 16. From the second parentheses, we get negative 8. Okay, so that's what y equals. Y is 16 and negative 8. But remember, we need to figure out what x is. And we can plug back into our substitution to get that. Okay, so we got to sub back into y equals 2 to the x. Okay, so I'm going to plug those values that we just got for the y. So we get 2 to the x can be 16, or 2 to the x can be equal to negative 8. Well, with that first one, 2 to the x equals 16, well, that one's pretty quick. We get x equals 4. For 2 to the x equals negative 8, so remember that this will have no solution. No solution, since we saw this before in this section, that if you do 2 to any power, that's always going to be greater than 0. It's always going to be positive. So there's no way it can equal a negative number like negative 8. Okay, so that leaves us with just one answer here. It's just x equals 4. Nice. Okay, so one quick comment I want to make about this whole thing about getting common bases is we've seen before that if you have something like 2 to a power equals 2 to a power, well, that means those powers are the same. A equals b. But I want to mention that if I had something like 2 to the 2 to the a plus 2 to the b, and then, I don't know, equals 2 to the c. So if I had, a couple of 2 to the powers on the left, and then 1 2 to the power on the right, there's no such rule here. I cannot just set the exponents equal. So with this, I can't set the exponents equal. I'm going to put that in a little thought bubble. That only works if on the left-hand side there's just 1 2 to a power term, and on the right side there's just 1 2 to a power term. If that's all that's there. Okay, all right, let's look at another example. So B. So I got x squared times 3 to the 4 plus x minus 16 times 3 to the x equals 0. Okay. So, we saw this idea of splitting up a term using an exponent property in the last problem. Let's do that with this 3 to the 4 plus x. So I can rewrite that, x squared still in front, times 3 to the 4 times 3 to the x. And then I still got minus 16 times 3 to the x, and then equals 0. And now that's nice, because in both of these terms, let me go to highlighter mode. There's this 3 to the x. There's 3 to the x in the first term and in the second term. So I can, because that 3 to the x shows up in every single term, I can just factor it out. I can factor out that 3 to the x and then write what's left over. So from the first term, what's left over is this stuff. 3 to the 4 is 81, and I get x squared. From the second term, what's left over is the minus 16. And that whole thing equals 0. So quick comment about this. How come in B I am factoring out that 3 to the x, but in part A I didn't factor it out. I substituted for it. So in B, every single term contained 3 to the x. So we could factor it out. But in A, not all of the terms contained 2 to the x, so we weren't able to simply factor it out. Like this very last term, that minus 128, that didn't have a 2 to the x. That's why factoring it out of everything wasn't going to be helpful in A. Okay. All right, so part B, let's keep going with this. So I notice that 81x squared minus 16, well, I got some difference of squares. This is something squared minus something squared. So with the 16, that is 4 squared. And the first one is 9x getting squared. So if I use my difference of squares, we got 3 to the x in front, and then we'll get 9x minus 4 times 9x plus 4. That whole thing equals 0. Okay, so now I'm ready to solve this thing. So when do each of these things equal 0? All right, so let's start with the 9x minus 4 and the 9x plus 4. From those, we'll get x could be equal to either 4 over 9 or negative 4 over 9. So plus or minus 4 over 9. And then, well, there's this other thing at the front, 3 to the x. When does that equal 0? Well, that never equals 0. 3 to the x never equals 0, since, just like with 2 to the x we saw it above, 3 to the x is always bigger than 0. It's always positive. Okay, so that leaves us with just these two answers, positive 4 over 9 or negative 4 over 9. All right, part C, I'm going to skip. This is going to be a warm-up problem for us next time. Let's jump ahead to last problem, part D here. On the back side, I got an absolute value, and then it equals 4. Okay. So for this problem, I want us to first think about, if I have absolute value of some stuff equals some junk. We talked about how to solve equations like that way back in our section on solving equations. This was, I think, section 1.5, back in chapter 1. So we can split this up. Remember, the first step of an absolute value equation is we isolate the absolute value, get it by itself on one side. So that's already done. That means we are ready to do this stuff in junk then. We can split it up into two possibilities, where the stuff inside, 2 to the 2x minus 12, that can be equal to one of two things. Either the junk on the other side, which is 4, or the negative of the junk, negative 4. All right, so let's solve each of these. In both equations, I can add 12 over. So 2 to the 2x equals 16 here. In the other equation, if I add 12 over, I get 2 to the 2x. 2 to the 2x equals 8. Okay, and now, well, I have common bases, because 16, well, that's 2 to the 4. And then 8, well, that's 2 cubed. Okay, so if I set the powers equal now, well, this power has got to equal to 4. And in the other equation, this power has got to equal to 3. In my first equation, that'll give me 2x equals 4. And dividing, I get x is 2. In the second equation, we'll get 2x equals 3. And then dividing, we get x is 3/2. All right, so we're getting two answers. You may remember from back in chapter 1 when we solved equations with absolute values. This is one of the scenarios where we needed to check for extraneous solutions. So we would have to check for extraneous solutions, meaning we'd have to take these answers, plug them back into the step where the absolute value is still there and see, do they actually both work? So I'm going to trust that we can do that. It's a pretty quick check. And I'm just going to say, they will both work. Turns out when you do that, both work. Both will work. Although if this was a homework or an assessment, you should definitely show that work. It's very quick. Both will work. So we got two answers. 2 as well as 3/2.